In this video, I'll explain the concept of units and limits commands. But before moving on to these commands, I'll teach you the various methods to input a command in Autocad. You're already familiar with the idea of a command. Suppose if I want to give the line command, I can do that by clicking on the line icon at the draw panel. When I click there, it'll ask me for the first point. I've clicked the first point. When I drag my mouse, I can see the length of that line as well as the inclination of the line segment with the x-axis. I'll just left click to define my next point and left click once more to define the next point. Likewise, I can draw this line. Suppose if I want to cancel this ongoing command, I can do that by pressing the escape key. Next, I would like to construct a circle. But this time, I'm not going to use the ribbon to choose the circle command, but instead, I'll type the first letter of the circle command, that is C. In Autocad, each and every command has got abbreviations, which we can memorize and input those abbreviations. So I'll type the letter C. When I type C, Autocad will list all the commands that start with the letter C. I can either give an enter to execute the circle command, or else I can choose any other command which starts with the letter C by picking against that command. So I'll give enter. It'll ask me for the center point, which is called the default prompt. So I'll just give a value which is say 500, 500. You can see that appearing at the cursor location, and press tab and again type 500 and give an enter. So the center is defined here at that coordinate location. Now it is asking for the radius. But instead of giving the radius, if I want to give the diameter, I can either click on the diameter option, or else I can type the letter which is given in blue color. Since here D is given in blue color, I can type that letter. But it's always easy to click against that option. Now it is asking for the diameter instead of radius. So I'll give the diameter of 600 units. So I'll give 600 and that will appear at the cursor location and give an enter. So in Autocad, by default, each and every inputs which you give appear at the cursor location. That is because the dynamic input is on. If this option is not displayed here, you can go to customization button. You can activate this option here. Once you disable the dynamic input, then the commands and the user inputs given will appear at the command line. By pressing the up arrow key, you can go backwards and you can see all the previously given commands, and by using the down arrow key, you can go forward, and by pressing the F2 function key, you will get all the previously given commands and the prompts. You can just scroll down and see all the details clearly. And this is what you call as the history. And if you want, you can just right click and copy this history and you can paste it onto any text editor for a future reference. And by pressing F2 again, you can close the history window. Autocad memorizes the most recently given command, which can be repeated by giving an enter or by right clicking the mouse. I'll just right click the mouse to get the context sensitive menu. Here, the first option is repeat arc. Since arc being the most recently given command, by clicking on this repeat arc option, I can repeat the arc command. I'll just press escape to cancel this. Now, I can also repeat the most recently given command by pressing the enter key. As you know, a keyboard has two enter keys, but in Autocad, the enter can also be given by pressing the spacebar. And that's the preferred method because spacebar is a larger key when you compare with the normal enter keys of the keyboard. In Autocad, you can always undo a command, and undo will reverse the effect of the most recently given command. For example, I'll draw a circle using the center radius method. Then I'll just give right click to repeat the circle command once more. Again right click, repeat circle, and I'll draw one more circle. Undo can be given either by typing U at the keyboard, or you can choose undo from the quick access toolbar. So I'll just give undo, so that circle is gone. One more undo, that circle is gone. With the third undo, you can remove the circle which you have drawn first. Now I'm going to give redo, and redo will always undo the undo. Now I'll give redo, redo, redo. I've got it back. But the redo should be given immediately after the undo. Otherwise, it won't work. Next, I'll talk about units command. Before we start any drawing, we have to set a proper unit. Basically, we create drawings in decimal and imperial units. In AutoCAD, when you work, we actually create the drawing in the true dimensions. Later on, while going for the plot, you can specify a proper scale to scale down the drawing or to scale up the drawing. So let's go to units command. You can type the letter UN for units and you will see the drawing units dialog box appearing, or else you can go to the application button, drawing utilities, and here you can see the units. You will see the same dialog box. We should set the units for the linear as well as for the angular measurements. For the linear measurement, we have architectural, decimal, engineering, fractional and scientific. In architectural units, you can draw in feet and inches. It is represented like a fraction, and feet are represented using single quotation and the inches are represented using double quotation. And if you do not specify any symbol along with the number you enter, your values will be treated as inches. And next is decimal. In decimal, the values which you enter will be represented in a decimal form. The next option is engineering. In engineering, you can have only inches. Fractional is basically used by cabinet makers, and here it is represented in inches but in a fractional form, as you can see in the sample output. And if you go for scientific, your units will be represented in the 10 to the power of e form. That means in the exponential form. Let's select decimal, because decimal is basically meant for metric and which is commonly used in India. Next, we have to set the number of decimal places. You can go up to 8 from 1 decimal. I'll set say 2 decimal places. Next, we have an insertion scale option. In AutoCAD, you can insert an external block, which is nothing but an external object or an external drawing into the current drawing. Suppose that external drawing is drawn in a different units. AutoCAD will scale that inserted drawing in such a way that its unit matches with the unit of the current drawing. Next, we can set the lighting units, which I'll set at international. We have 3 options here, and we have the system of angular measurements, which is decimal degrees, degrees, minutes and seconds, gradients, radians, etc. And the commonly used system is decimal degrees. Here also you can go for the number of decimal places for the angular measurement. And by default, the angles are measured in the counterclockwise direction or anti-clockwise direction. But if you want the angles to be measured in the clockwise direction, you can just click over here. Now just click on the direction button to set the base angle position. By default, the base angle is set at east. That means rightward, the positive x-axis direction. If you select north, your 0 angle will be set at y-axis direction or in the north direction. You can choose any desired option. I'll set it at east, which is the default. Now you can just give OK to go out of the units command. Next, I'll talk about the limits command. But before exploring the concept of limits, I would like to give you an overview of the coordinate setup in AutoCAD. This AutoCAD screen is assigned a Cartesian coordinate setup, and the same coordinate setup which you have learned in coordinate geometry. And this particular icon indicates the directions of x-axis and y-axis. But there is also a z-axis which is coming towards us. If you want to see the direction of the z-axis, you can just hold down the shift key and press the scroll button of the mouse. You can tilt the coordinate setup and you can see the z-axis. Okay, I'll just give undo to cancel this operation. There are grid lines on the screen running in the horizontal and vertical directions, just as you see in a graph paper, and the distance between each grid line is set at 10 units by default in both directions. If you want to change the grid spacing, just right click and you can go to grid settings. Here you can change the spacing from 10 to any other value. And if you want, you can suppress the display of grid by pressing here, and you can press once more to get the grids back. Or you can use the F7 function key to control the display of grids. Similarly, there is a snap option available. When the snap mode is on, the cursor jumps from one grid point to another. For example, if I try to draw a line, you can see that the cursor jumps from one grid point to another. And this feature can be used to precisely locate points. Presently, snap and grid spacing is given the same value. But if you want, you can change the snap spacing. For that, you have to right click on the snap button in the status bar toggles, then go to snap settings, and here you can give a new value if you want. Snap mode can be enabled and disabled by pressing the F9 function key. I hope you have got an idea about what snap and grid is all about in AutoCAD. Now let's come back to the coordinate setup. Over here we can see the first quadrant. Now I'm going to pan my screen. When I pan my screen, you can see that the origin is getting shifted. Now you can see the first quadrant here, second quadrant here, third and the fourth quadrant is also visible. So likewise, you can bring in all the 4 quadrants within the screen if required. Now I'll right click and exit. You know that AutoCAD screen is infinite in nature. It's just like our universe, and it starts from minus infinity and goes towards plus infinity in all directions. But as a user, you don't need the entire screen to work. But instead, you need just a rectangular area from the screen. For that, you have to set a limit to define this area. So setting limit is defined as a process of defining a rectangular area from an infinite screen to perform drafting or modeling. A rectangle can be defined conventionally by inputting length and width. Or you can define it by inputting 4 corner points. But do we actually give 4 corner points? No. In limits command, you actually define the lower left as well as the upper right corner. So how will you define the other 2 corners? The coordinates of the other 2 corners are calculated from the coordinates of the lower left as well as from the upper right corner. The coordinates of the upper left corner is obtained by extracting the x coordinate from the lower left and y coordinate from the upper right. Since the lower left and the upper left are along the same vertical line, the x coordinate of the lower left and the x coordinate of the upper left will be the same. Similarly, the coordinate of the lower right is obtained by extracting the x coordinate from the upper right and y coordinate from the lower left. So this is how all the coordinates of a rectangle is obtained. When you set the limits, AutoCAD will activate that area for the user so that the user can perform 2-dimensional drafting or 3-dimensional modeling in it. Now, after you set the limits, we have to zoom that area so that it will fill up the entire screen. So this is a very important step to be followed. So I'll go to zoom command. So type Z for zoom and you select the option all. When you click on the all option, the area which you have defined in the limits will fill up the entire screen. From this illustration, it is clear that the limit which you have defined will be center justified with respect to the screen. But you can always draw outside the limits if you want. If you do not give the zoom commands all option immediately after setting the limits, what happens is your limit may sometimes remain at a corner of the screen. Sometimes it may be lying outside the screen. In both the cases, the moment you give zoom all, it will fill up the entire screen and it will remain center justified within the screen. Now let's see some live examples of 2-dimensional drafting so that you will get a better understanding on setting the limits. We will set a proper limit to draw this figure. When you go through the dimensions, you can see that there is no negative values in this figure. So you can keep the lower left corner at the origin at 0, 0. And how will you define the upper right corner? For that, you have to go through the figure and locate the maximum dimension. The maximum dimension is 100 units in this. So you have to define the upper right corner in such a way that its value is above the maximum dimension to be plotted. Since the maximum dimension is 100, you can give a value something like 125 or 150. So we will give the limits command to do this. I'll give limits. When I'm asked to give the lower left corner, I'll give 0, 0. And when I'm asked to give the upper right corner, I'll give 125, 125. Now I should give a zoom all. I'll give Z for zoom and A for all, or else you can just click on the all option. Now this screen can properly accommodate that drawing. Next, we will consider this example. In this figure, we have 5 circles and each circle at the corners has got center point located at each quadrant. Center point of this circle is at 35, 35, which is in the first quadrant, and this circle is in the second, and this is in the third, and this circle is in the fourth quadrant. How will you find out the coordinates for the lower left corner to set the limits? Here, the coordinate is minus 35, minus 35. That means you should give a value which is below minus 35 so that the circle will be within the screen. So we should add the radius along with this 35, which is 17.5. So 35 plus 17.5 is 52.5, which will be this particular point, and we should give a value which is again lower than 52.5 so that this circle will be well within the screen. So I'll give say minus 60 as the lower left, and the upper right should be obviously 60, So likewise, by setting the lower left at minus and upper right at plus, you could bring all the 4 quadrants within the screen. So that is how the limit for this particular figure is set. So let's give limits command in AutoCAD to get these limits on the screen. So I'll give limits, and the lower left, when I am asked, I'll give minus 60, and the upper right, when I am asked, I'll give 60, followed by Z for zoom, and I'll type the letter A, or I'll click on all to get the limits on the screen. But obviously all the 4 quadrants must be in the screen, but the origin still remains here. If you want to see the origin of the UCS icon exactly at the actual origin point, you can give a command called UCS icon, and you can select the origin option. Just click on the origin. Now the icon will sit exactly at the origin point. Now from this, it's clear that we have brought all the 4 quadrants within the screen. So from these 2 examples, I'm sure that you must have got an idea about the concept as well as the criteria to set the limits. Okay, so that's all about this tutorial. In the next tutorial, we will see how to create basic objects such as points, lines, circles, etc.